presentation is to reveal key results from this research as we identified 11 leading vendor solutions that met what we view as all the key requirements for an all-flash solution. So let's take a quick look at our agenda for the day. What we're going to do is start with kind of really a brief overview of the flash market landscape, because all flash storage solutions are one of a number of different options that are available out there. We'll discuss the evaluation process we used in scoring the various vendors, and followed by the elements that were considered in that scoring process. And this will be followed really with the primary results of how the different vendors stacked up against each other. And we also have a couple of rewards for special recognition for solutions that were innovative compared to others. One of the first things I like to do before we get into the solutions themselves is just talk briefly about flash storage technologies. You've probably heard these terms. SLC, MLC, TLC, it's really relative. A flash is really made up of many, many individual cells, and the number of bits contained within those cells increases as I go from SLC to MLC to TLC. And although the density increases, there is a declining amount of endurance and also performance. What we find is that many vendors actually like to use a combination of these technologies. For instance, MLC for the landing zone for the most active data, and TLC for the colder data that isn't going to experience very many write operations, so the endurance is not that big of an issue. And then lastly, latest to the market is 3D technology. Flash actually has reached a limit to how small the geometry can be for a given cell. So to further increase densities, the 3D approach actually, as it sounds, layers cells on top of each other within the same geometry, and therefore able to increase additional density in that fashion. So from the landscape standpoint, there's a number of different flash options available. There's server side or DAS. Server side came about around the 2008 time frame with flash that plugs into the PCIe slot on the server, extremely fast, super fast latency, but because of the restraints within how much you can put on one of those cards within the server, there is a limited amount of capacity. So typically these solutions tend to house a single application, dedicated application. Hybrid storage arrays came about as vendors took solid-state disk drives and intermixed those with spinning disk drives on legacy storage solutions to increase performance. However, the amount of performance that could be achieved was limited primarily because these systems were not specialized to take advantage of flash. So again, the overall benefits are somewhat limited. Not so today. The hybrid solutions today are that which contain both flash and spinning disk are very much optimized for flash, and a typical use case is to again have most active data on the flash and move colder, less active data off to spinning disk. First generation all flash arrays really took the concept of high performance specialized flash. Initially that was within the PCIe cards, and by putting that out in network storage was be able to scale to much larger capacities. However, the processing at that time was somewhat limited on these systems, so any kind of storage services such as deduplication or replication, etc., were not provided, and if those were needed, they were done so by the applications themselves. And now we have what I refer to as second generation all-flash systems. Processing has increased, thanks to Moore's Law, to a point to where storage services can now be deployed without impacting the flash performance itself. And also, flash pricing and costs have now really approached, and in some cases gotten better than the 15K and 10K high-performance spinning disk drives that were typically used for primary storage. So this has enabled all flash arrays to now be extended into uses for primary storage and for consolidation efforts within the enterprise. And it's this last category of all flash arrays that this radar will be focused on. So what are the benefits of all flash? Of course, performance is one. IOPS really represents the amount of work that can be done within a given amount of time, and latency is really how long it takes to perform a single operation. And latency is really the key to consistent performance in flash, especially when one gets into mixed workload environments. So most all-flash vendors do quote a latency of about a millisecond or sub-millisecond. You do see some, though, that get down to 500 microseconds or even less. The lower the latency, the more consistent the performance is going to be, and the more capable of being able to consolidate mixed workloads. Administration is easier. Why is that? A lot of time on spinning disk is spent with mixing and matching different types of data with different access characteristics in the same physical location to try to blend performance across a whole system. The problem with that is it's very labor intensive and often becomes obsolete once workloads actually begin to be utilized throughout the day. And with flash, with the lower latency, administrators can take more of a just store it and forget about it type approach, so it really reduces the amount of effort on their part. More efficient storage, also with spinning disks, there's a limited number of IOs per spindle. It's, with 15K drives, it's around 200 IOs. So in order to achieve the results needed, often there was an oversubscription in the number of spindles, several times more actually than what was required from a capacity standpoint just to meet performance requirements, and with flash that's no longer needed, so lower capacity amounts can be used to achieve performance needs. Also, data reduction, deduplication, which has been used for years on spinning disk with secondary type storage, backups and archives where performance is really not that strong of a requirement, really wasn't viable for primary storage, primarily because of the impact of performance, especially on the processing end of things. With flash, the lower latency, deduplication can be performed with some performance degradation, but still significant performance can be achieved even with deduplication, and which ends up with data reduction results of about 4 or 5 to 1 in a typical enterprise. And then lastly, smaller footprint and lower environmental consumption. If I'm using less flash than I've had to use for physical storage, and the fact that I'm using deduplication, for instance, compared to a 15K drives, I can use approximately 15 times less floor space and 15 times less power. So certainly operational benefits that are there, as well as the performance that one can achieve. And also it extends the life of legacy storage. Once the highest performing workloads are taken off, performance is now adequate for what remains on those spinning disk drives, and they can continue to be used to the end of their economic life. So use cases for flash, really it's what flash does is it's able to remove the need and the delays required for seek operations. So it's really where random IOs, especially with reads and small blocks, is really where the greatest benefits are realized. The types of use cases that benefit our databases, OLTP, and certainly analytics, things that have to hit the storage systems hard, fast, and often. Also virtualization. Virtualization places extra stress on storage systems because of the consolidated server is actually placing increased I/O density to the storage systems, and that storage systems had started to become quite a bottleneck for virtualized servers, but the lower latency of flash is able to accommodate and solve that. VDI, virtual desktops, typically don't need high performance throughout the day, but there are events such as when all the systems have to boot at the same time, called a boot storm, can provide a great degree of stress on a storage system, and which could cause really some dissatisfaction with customers. And again, the low latency of flash is able to accommodate that. Also, dense workload consolidation. Different workloads can now actually be consolidated on the same system. Again, primarily because of the low latency, is able to achieve that without impact. And then tiering. Tiering is that concept where, as I mentioned earlier, I can put more active storage on flash, less active on spinning disk. The net effect is I'm able to get higher performance while being able to retain a lower cost of operation and ownership by using some lower cost, high capacity spinning disk as well. These high capacity drives, which tend to be 8 to 10 terabytes, as opposed to the high performance disk drives, are still quite a bit less expensive than flash. So let's talk about the Radar report. Really the purpose is really for comparing enterprise class all flash systems that have the capacity, performance, and importantly the storage services to support primary storage workloads and enterprise consolidation efforts. So just a few things to qualify. Number one, the products and their features have to be generally available at the time of the research. Systems have to be available as all-flash configurations. A hybrid system, in our case, does qualify as long as it has an all-flash configuration option to it. And then, in order to meet those, really the consolidation benefits, had a raw single enclosure capacity of at least 100 terabytes of raw capacity. That is raw and not without any data reduction, or 200 terabytes in a clustered or multiple enclosure environment. So what's some of the key criteria that we look at for a study such as this, which is really an independent and objective comparison? We look at deployment and administration, which is really about how easy is it to implement and utilize the platform. Cost advantage is really about not only the price of the product, but how much is maintenance, and are there data reduction capabilities available that can further reduce costs, and also are there programs that allow for products to be upgraded over time, which could extend their economic life. From a solution impact standpoint, we look at functionality. It's really the breadth of features that the system has that would be required for a flash that can perform consolidation of mixed workloads, et cetera, and also architecture and integration. How well does the hardware and software design integrate with external third-party solutions? And then vendor strength, maybe the one that's perhaps least known to some folks. It's really, this is about industry presence, the long-term strength and viability, of the solution provider, and their commitment to maintaining and improving the platform. So if you're going to invest in a solution for the long term, you want to make sure that that vendor is going to be around, and they're also going to be providing investment into improving that product. So we're going to talk about now the characteristics of a preferred solution, and these characteristics are factors that were used to identify how well one vendor solution compares against each other. And the first with architecture and integration, we want to take a look at which kinds of protocols and data are supported. The ability to support both block and file, and if applicable, object storage has a great advantage from a consolidation standpoint, and also provides a degree of flexibility in actually changing applications without having to change storage systems. Integration with virtualization, which virtualization providers are supported. 80% of servers out there today are virtualized with all different types of vendors, and the ability to support a wide breadth certainly is of value. Scalability, how can I meet not only today's requirements, but those in the future? Can I scale to meet future requirements? Also, can I scale independently things like performance versus capacity, which could be a more cost-effective way of meeting future needs without having to procure resources that are not needed. And also APIs and direct integration with third-party platforms, for instance, with VMware vSphere, the ability to provision capacity or perform various functions within the storage directly from either virtualization software or another type of product. Functionality, as I mentioned earlier, that those first generation of all-flash systems often did not have storage services. And again, if the system's going to be used for primary storage, these kinds of services that the enterprise has grown to depend on must be there. So we took a look at if these were supported by each solution and how well they did. Data protection, snapshots, the ability to do both snapshots for local recovery as well as remote. Deduplication and compression are data reduction technologies that provide greater cost of ownership. Encryption, you take a look now, it's not only a corporate objective and requirement, but encryption's also, for many reasons, required from a regulatory standpoint, especially for use cases such as healthcare or financial services. Thin provisioning, it's another data efficiency, or I should say capacity efficiency capability. The ability to provision storage to users, but only consume the amount of capacity that's actually written on the device. Replication, disaster recovery is obviously a must for all enterprises today. So replication that is completely integrated and easy to use is a key requirement. And then clones. Clones is a way to make copies of volumes or virtual volumes, and following the creation of a clone, one could then take snapshots of that and create various copies that could be used for different purposes, perhaps for a use case such as analytics. There's no doubt that performance is important for Flash, so we did take a look at a couple of different aspects. Certainly IOPS, as I mentioned earlier, a lot of the systems scale IOPS as they get larger, often in a linear fashion. So that was taken into consideration. And then we took a look at the average latency of the system, and also maximum and minimum latency numbers to get a sense of how consistent performance was going to be and how well the system's going to work in a mixed workload environment. And then also, I'm using this for primary storage. My most important applications, reliability, availability, serviceability is very important. So how Flash durability is extended with software, the ability to use multiple controllers to maintain availability in case of an outage, and other things such as CRC, RAID, of course, or some alternative is required to assure systems remain available. Now we're going to take a look at cost advantage. As I had mentioned earlier, we're taking a look not only at a list price, but also things such as data reduction and capacity guarantees. Upgrade programs were also considered. The ability to maintain viability of a solution when new versions come out, or even more of importance of value, the ability to upgrade different aspects of a system were considered. Not only does this reduce capital expenditures, but it also provides the capability to reduce or increase depreciation period. And of course, maintenance, the warranty and the cost of maintenance compared to list price was looked at. Deployment and administration, how difficult is the system to set up and configure? How intuitive, is that management console? Does it have a great dashboard that I can drill into? Does the system have QoS? That was certainly a key weighted score within this particular area. Different applications have different levels of priorities, and to be able to assign different performance resources to those relative to others is very critical, especially when I'm now consolidating and putting a lot of different workloads on the same system. Also, independent management capabilities. Orchestration and automation, throughout the enterprise, is key. And then open standards, things like OpenStack, REST API, SMIS, as well as things like the incumbent VMware, vCenter, these third-party methods of being able to manage the flash are very important and provide a great deal of flexibility for the enterprise. And then lastly, vendor strength. As I mentioned, vendor strength is really about how strong is a vendor, what's its long-term viability, is the product going to exist for a period of time, and you certainly, again, want to make sure that if you're going to invest in a solution, that the vendor is going to continue to invest in that so you can continue to leverage that solution over time. So what's the process, really, of this radar report is a couple of things. First is developing a list, really, of critical features and capabilities that's needed for an all-flash solution, and then from that, create key product indicators or KPIs. And what these KPIs are really all of those capabilities, and then there is a weighting that is applied to those, and then that's weighting is based upon our many conversations that we have with end user customers and what's important to them, as well as our own inherent knowledge that we have here. At that point, we make a determination of what are the minimums that a solution has to have to participate in this radar exercise. We identify candidates and then create a very comprehensive survey with over 150 points to be identified that we send out to the vendors for them to fill out, and often we have those are followed up with conference calls to go over those particular things in depth, and we take the time to vet these responses independent of the vendor for accuracy. We also ask the vendors for customer contact information, and with that, we contact those customers to get their experience with the product, and we validate the things such as performance and ease of use and how much they paid for the product, etc. And following all that, we then calculate scoring by correlating, features, pricing, and capabilities against the predetermined KPIs that I mentioned earlier. And these scores are used in the product comparison chart. So with that, I'm kind of proud to show the all-flash radar market landscape chart. Really, this chart defines value as a ratio on two different axes from the strength of the product, which is really the vertical axis, against its core efficiency, which is the horizontal. Basically, the vertical axis combines the scores of functionality and integration, and the horizontal axis combines the scores of cost advantage and deployment and administration to define the full deployment cost efficiency. And together, really, deployment and cost capture both the CapEx and OpEx costs with the total cost of ownership of a solution. So based on where vendors score in those two areas is where they end up in the chart. Lastly, a fifth element is the bubble size is an indicator of the vendor strength that I had talked about earlier. So vendors that most effectively balanced solution strength and cost efficiency landed in that dark green triangle in the upper right and are identified as value leaders. So of the many vendors that are out there, we've identified and limited, based on our KPIs, 11 solutions that are represented here that are leading provider of all-flash storage. By extension, any vendors not noted here would fall to the lower left of the chart based on KPIs and were therefore not included. So with that, let me talk about the vendors, the value leaders first. Dell really greatly improved, their all-flash solution with their introduction of the SC9000. They added deduplication and a strong set of services, including application, crash consistent snapshots, thin provisioning, auto tiering, synchronous, asynchronous replication, all the things that the enterprise needs for a primary storage solution. And we also found Dell to be very aggressive with pricing and also a lot of value in the fact that they support both file and block storage. The EMC Extreme IO, boy, this product's been available. We're coming on 2 years, and this has really been EMC's fastest selling product ever. They're at over a $2 billion rate, as opposed to their initial forays into the industry. Extreme IO was really built from the ground up to be an all-flash system and has extremely good performance at 500 microseconds of average latency. In the customers I talked to, they said they had to give no thought to data placement. They just stored it and forgot about it and achieved all the performance that they needed. Extreme IO also has a very valuable feature, integrated copy data management. What this does is it delivers instant, unlimited memory copies, that are space efficient, writable, and perform consistently. So a lot of secondary copies of data can now be done more efficiently and with high performance within Flash. HPE has a couple of solutions, the 20,000 and the 8,000. This analysis was done on the 20,000 product. It's a very, very large capacity and scalable systems that can scale up to 4 petabytes of raw capacity. It provides, again, like the EMC box, great average latency of 500 milliseconds, and also can, as a minimum latency, as low as 280 microseconds. It, like the Dell box, also supports unified block and file, which again can reduce the number of systems that are required as well as the administrative effort. If I take a look at IBM has a recent addition, the A9000R. One of the things that impressed me really about the A9000R was its new user interface. It really provides a very holistic view of the management experience, provisioning, monitoring, troubleshooting. These are all available, from a single screen. There's a very good health dashboard that provides insights, into connectivity, hardware, capacity, snapshots, mirroring, and migration. And there's some dynamic what-if tips that are provided to determine what the outcome would be with various configuration changes that administration is considering. The A9000 added a feature that was missing from the previous V9000, which is very critical, which is deduplication, which of course provides a greater degree of cost efficiency. Caminario, with their latest version, they've really gone to a more software defined architecture. What this enables them to do is really leverage commodity hardware. And it enables two things. They can more quickly respond to advancing hardware technologies, and it also provides them with a greater degree of flexibility of being able to upgrade existing systems in the future. They take a grid clustered approach to storing data, and the data is continuously redistributed across the grid to maintain the lowest possible latency and highest IOPS performance. And with their latest release of 5.5, something that was missing with Caminario, native replication capability has been added with that system. With that, Pure Storage rated very high in our study from its ability to have very high performance in a scalable fashion, as well as with a very complete set of storage services needed, which are really needed for the enterprise. Another thing that Pure has is probably the best program to be able to upgrade hardware, including even controllers within the system as new advances come out in processing and other areas. So that allows customers to initially invest in a Pure Storage, take advantage of all the capabilities that it has, and then be able to expand and also modify that system to take further advantage of technology advances that come into the future. So with that, we'll take a look at our strong value providers. HDS, has been strong in the hybrid space, and their F series that they announced is an all-flash system that utilizes their own proprietary FMD DC2 design flash module. And what that module does is it's able to really leverage the inherent advantages of flash technology. As an example, the FMD DC2 flash module utilizes inline compression within the flash module, which greatly increases performance and reduces the overhead on the storage system processing requirements. The thing about HDS, they have a very, very loyal following based on their history of reliability and availability while delivering very, very good performance and a high degree of functionality. NetApp is a vendor that has several flash solutions. They have an all-flash FAS, an EF series, and SolidFire, which was a recent, I should say, not a recent, but an acquisition made for them sometime back. What really SolidFire was acquired for was to address, the growing segment of enterprise hybrid users and service cloud providers. And what that segment really needs when you've got a lot of different users on the same system is a multi-tenant web scale flash solution, which is what SolidFire delivers. So we made a choice of going with SolidFire as the solution for this particular report. Strong within that solution is a guaranteed quality of service. It sets an exact level of performance across multiple workloads, and sets user thresholds as a way to ensure needed performance is there for every application. And SolidFire is also now offering a software-only version of their product for probably very applicable to hyperscale users that want to use commodity hardware. Also, Pivot 3 is a hyperconverged company initially, founded in 2003, and they have in 2016 acquired NextGen Storage, and NextGen has been a long-term provider of hybrid storage appliances and all-flash arrays. And one of the things that NextGen does is they use a tiering model within their system to provide all of flash, to provide different levels of performance depending on how active the data is. For instance, it utilizes RAM, as a read cache for overall latency, PCI flash, then data is moved to PCI flash for low latency for relatively high access data, and then once data cools off, it will move that data to lower performing SSDs. And so the net benefit of this is achieving performance requirements in a very cost-effective fashion. Tegile is a privately held company, and really their IntelliFlash management really provides, again, a holistic view of the number of elements and metrics, that administration is going to want to view, on a periodic basis. I found, they did a demo for me, and that this interface is very intuitive and easy to use. Again, to get to any particular area, it takes just a few clicks. Tegile also natively supports SAN and NAS storage protocol, iSCSI, Fiber Channel, NFS, and Samba. And so by really supporting the unified block and file workloads, again, the number of systems required within enterprise can be reduced. And Tegile also has a roadmap. They're very, very committed to deploying NVMe, both within the storage system and externally for connectivity to servers in their long-term roadmap. And lastly, Violin. Violin is one of their early entrants into the all-flash market system. They had one of those first-generation systems that I talked about earlier that focused almost exclusively on performance and not as much on services, but they have now been developing systems that take advantage of the processing and lower cost of flash to be able to move into primary storage and consolidation efforts within the enterprise. The thing that Violin does is they really use custom engineering of firmware, software, and hardware to be able to achieve the highest degree of performance within the system. They have over 6,000 installed systems, a very recognized brand. One thing that I note is they may, to meet some of these cost curves where flash is headed in the future, may have to take a more commodity approach. A couple of special recognitions. First off, I mentioned Pivot 3 earlier. The Pivot 3, the N5 3000, it has really high performance capabilities and a great set of enterprise features, but it's really the QoS, in the N5 3000 that really sets it apart from a number of other solutions. These QoS policies can be selected by administration to set performance maximums for IOPS and megabytes per second, as well as latency minimums and maximums. Also, the data placement algorithms, as I mentioned earlier, they use a tiering approach, are utilized to connect and provide these differing QoS levels. This way, for instance, higher priority volumes will consume, the faster PCIe flash versus the slower SSD. So the QoS is a significant improvement from a couple of years ago when NextGen was really limited to identifying volumes that fell outside of QoS banding, but now they take a very proactive approach to meeting individual application requirements. And also Pure Storage, they are very unique in their investment protection via the Evergreen storage program. With traditional solutions, a customer is likely to go through multiple, perhaps 2 or 3 or maybe even more forklift upgrades over a 10-year period. This includes the need to repurchase hardware, rack and stack that, and then migrate data. This whole process of having to change out hardware continuously is expensive and time-consuming. And what Pure offers with Evergreen, is really the ability to evolve the system for up to as much as what they're claiming in 10 years by being able to add capacity, increase density by using for instance, by using new flash types, and again, even this is really unique, upgrading controllers to increase performance, increase capacity, either the amount of capacity or amount of connectivity or the type, and also include new software features. So this really extends the life of the product and also has the ability to enable the financial folks to go with longer depreciation periods for that investment. So with that, I'm going to turn things back over to Raleigh to see if we have any questions we can answer.
Thank you, Jim. Yes, let's take one question. It is, I keep hearing about the all-flash data center. Is that a viable option now?
Well, there's a lot of technical questions. Often the first part of the answer is it depends. So there's no doubt that with the lower cost of flash, the use of flash is certainly being expanded within the enterprise. As I've mentioned all along, it's moved from dedicated Tier 0 applications into primary storage. However, there still is data in many enterprises that is accessed very, very infrequently, especially archive data for that is used perhaps for regulatory purposes. So 10 terabyte hard drives, are now available, and these drives are still about 1/15 the cost of flash, so they're still a very viable option for this long-term archive data, especially if it contains things such as images that deduplication cannot take advantage of. So there's no doubt that flash continues to expand within the enterprise. Disk will be around for some time over the next number of years, especially for secondary data such as backup and archive.
Great. Thank you, Jim. And I wanted to thank our audience for joining us today. You will receive a follow-up email from Enterprise Management Associates that will include the on-demand playback as well as some additional resources. Thanks again for joining us, and enjoy the rest of your day.
Thanks, Wally.